Okay, now we're going to do part two. Now, the part two is going to look really confusing when you look at it at first. But once you see the algebra, it actually goes pretty quick. So let's look at the algebra. I know. You're looking at that saying, how am I going to solve that? Well, let's look at it from an algebra standpoint. Let's take the original function, and that is the square root of x plus 1 minus 2 all over x minus 3. Now, the question is, what on earth can we do to get rid of this radical right there? Actually, it's pretty simple. Can you all remember the word conjugate? All right, you got to take the conjugate. And in this case, the conjugate is going to be multiplied by the square root of x plus 1 plus 2 all over square root of x plus 1 plus 2. Now, it does a couple things. First of all, when we multiply the square root of x plus 1 times square root of x plus 1, that's going to give us x plus 1. Let me rewrite that again. It was not supposed to do that, So I got the square root, I end up with x plus 1, and then that's going to be minus 2 times plus 2, that's going to be minus 4. So it's going to end up being, when we simplify that, we'll simplify that in a moment, and then it's going to be all over x minus 3 times the square root of x plus 1 plus 2. All right. Hopefully I haven't lost you yet. Because then, once I combine the like terms, it's going to be x minus 3 all over x minus 3 times square root of x plus 1 plus 2. Think of it like this. If you take x plus y times x minus y, you're going to get x squared minus y squared. That's exactly what we did. This is our x term, and that's our y term. So x squared, y squared. That's all it is. Think about that. If you have any questions about it, send me an email. All right. Now the question is, what happens with these x minus 3's? They cancel. And I'm left with 1 over the square root of x plus 1 plus 2. And then for now, I just plug in 3. So the limit is equal to 1 over square root of 3 plus 1 plus 2. And then that's just going to be 1/4. 1/4. Okay, adjusting it for a little bit. All right. Now we're almost done here. There's one more example that I want you to, and then we'll go to actually, I'm looking over my information right here. Okay. Now, okay, one trigonometric example, I'm just going to give it to you. It's the limit as x approaches 0 of sine x over sine x. It's 1. I got 2 words for you. Know it. Learn it. All right. And then sometimes, what do we do when we do direct substitution? You could practice that on your own, and it doesn't look continuous at x equals 0. That's something you can explore on your own, and we'll talk about it in class. All right. So now the question is, we talked about this one time before. What was the limit as the absolute value of x over x as x approaches 0? Well, remember, we did this example the other day. or in the other lesson, that is. This is from the negative side, and this is from the positive side. So, since it's approaching from the left, it approaches -1. From the top, it approaches +1. So therefore, does not exist. That's what you need to know. Does not exist. All right. Okay. A little bit more you can kind of read over on your own. Now, okay, sketch the graph of f of x equals cosine x on the interval. You can do that. Determine the range of that. The range, remember, it goes from as high as 1 to as low as -1. So it's going to be determine the range. It is going to be from -1. And there's multiple ways of writing this. That's just how I usually write it. Okay. Now, cosine of 0, as you know from pre-calculus, is 1. The function, when the function is at pi over 2, it's at 0. When it's at -5 pi over 4, what's it going to be? You can do that on your own. You can type it in on your calculator. And the same thing with 3 pi over 2, -3 pi over 2, that is. I'll let you do that. Now, you will notice that each of those is an example of a continuous function. It just goes up and down and up and down. But is there an example of a trig function that is not continuous? In other words, one, it doesn't just go up and down, up and down. If you think about it, tangent and cotangent. Because remember, with cotangent and tangent, type in the tangent function, you'll see y. Type in the 1 over tangent, and you'll see y as well. Both of them are not continuous. They both have asymptotes. That's why. They have asymptotes. All right, so that's why they're not continuous. Okay, now, below that and next to that are just some rules. And I'm not really going to spend a whole lot of time going over them, but I will show you this. The limit of sine of x as x approaches c is sine of c. Limit of cosine of x as x approaches c is cosine of c. Same thing with tangent, cosecant, secant, and cotangent. So those are all. Now, without a calculator, determine all these limits. I'm going to tell you right now, they're 0. 0, 0, 0, 0, and 0. You can plug it in on your calculator, and it's still going to be 0. All right. I'm almost wrapping it up. I'm trying to get this done quickly so you can get to work. And if you need to rewind it back, you are more than welcome to go do that. Now, 2 special theorems you need to know. Memorize these. Learn them, because you're going to need it. The limit of sine of x as x over x as x approaches 0 is 1. And the limit of 1 minus cosine of x over x as x approaches 0 is 0. Now you could see a proof of the first one called the squeeze theorem. You can get on this, you can access this particular YouTube page and check it out for yourself. I'll let you do that. So, all right. Now, for next time, actually for this Friday, the 21st, I want you to complete page 84, this particular problem set. You can save it, you can type it on a Google Doc or place it on a Google Doc and share it with